Okay, so in today's class, we are going to discuss about the Arduino architecture and programming. Right, so we'll move on to Unit 5. So already you have experimented, you have used this Arduino board in your laboratory, right? So today we are going to see about the architecture of Arduino and how can you proceed with prototyping Arduinos. And to start with this, Arduino has, you might have already seen this board in your laboratory sessions. So the Arduino has few digital pins, which is used for programming. You can connect your sensors, your motors, your relays here, and you have a reset button. Then you have your USB port for connecting to a computer to upload the program. And here is actually the microcontroller. So the microcontroller used in Arduino is Admega 328 microcontroller. Then you have a power jack where you can connect an adapter and give a power to this Arduino board. And it also has few analog pins to connect your sensors, analog based sensors. And then you have a power supply. So we have the voltage in, we have two grounds, and then the 5 volts. So this is a board which you might have worked 6 of your experiments in the laboratories, right? So and the main part, the core part of this Arduino is this Admega 328 microcontroller. So this is a central processing unit. So this is responsible for all the processing part of this Arduino board. Okay, so this is actually a brain of this Arduino, and the clock speed is 16 megahertz. Okay, so it process your instructions, your programs, to the frequency of 16 megahertz. All right, and regarding memory, so your Arduino board has a little bit of memory in order to store your program, in order to store your temporary variables that you initialize in your program. So first it has a flash memory. Okay, so this is where as soon as you upload your sketch, so you will use Arduino IDE to program, and as soon as you upload your sketch, this is where it is stored. Okay, so and you might have seen that it uses, okay, so when you are uploading the code, okay, so it will, you will have 32 KB of memory. Okay, and of which 0.5 KB is used for bootloader, and you will be uploading program to the tune of 0.2 KB, or maybe very less, few codes you might have uploaded. So when you upload, you will get sketch uses this much byte. Okay, 6% of your flash memory. Okay, so maximum memory available is this. So if you check that maximum memory available, it will be around something 32,256 bytes. It will show in that way, right? And then you have the static RAM, which is used to store your runtime data variables. So Uno has 2 KB of SRAM. So whatever initialize you variables, you initialize the int, the port pin numbers, sometimes some variables for computations inside your programs. You will use all those variables, right? So all those are stored in the SRAM. And there is also EEPROM. Okay, so it is also used to store your permanent data. Okay, so whenever you want your data to be available in Arduino, but it should not be vanished when, even if it is switched off. In that case, you will go for EEPROM. And the next one is the power supply. So power supply, usually how we used to power the Arduino is using the USB port. So as it serves double purpose, it helps us to upload the sketch as well as it helps us to power the Arduino Uno. So that's what it is given. It can be powered either by USB or by a power supply adapter. A normal adapter will do good for powering up the Arduino. Okay, so and there are also voltage regulators. Suppose more voltage are coming in, the sensors may get damaged, the Arduino boards may get damaged. In that case, there are voltage regulators to maintain the voltage. So the Arduino Uno especially has two voltage regulators, one for 5 volts and one for 3.3 volts. Okay, and then we have a lot of input output pins available in Arduino. So as we see in the architecture diagram, the first set is we have 14 digital pin. Okay, and among those 14 digital pins, we use very heavily for connecting your sensors, your buttons, your LEDs, your displays. Okay, And among that, the 13th pin, okay, so 13th pin has a default LED connected to it. Okay, so by default an inbuilt LED is connected to the 13th pin. Okay, and then there is also PWM pins. So PWM pins, usually they are 3, 5, 6, 9, 10, and 11 of Arduino. So these pins are used for based on your frequency. If suppose you want to control a motor, you want to dim your LED, you want to make LED bright. Okay, so in that case, you will be programming these pins. Okay, so if you want to vary the intensity of LEDs, if you want to vary the speed of motors, then in that case you will go for this pins. And then also you have certain analog pins in order to connect analog sensors like temperature sensor, LDR sensor, and all those sensors. Then you have the serial peripheral interface, and then you have I2C pins. Okay, there are two I2C pins. I think it is fourth and fifth pin of your Arduino. So usually whenever you're connecting your LCD display, we cannot sacrifice that much of pin to connect LCD display. So we will be using something called I2C chip. Okay, we'll interface the LCD display and the Arduino using I2C chip. Then this I2C chip, SDA and SCL has to be connected to only certain pins of Arduino. Okay, so then that is used. Then there is also pin 0 and 1. So 0 and 1 usually it is used for serial communication. See, whenever you connect a Wi-Fi point, okay, Wi-Fi module or a Bluetooth module to Arduino, we'll be using this 0 and 1 pin. So these are the input output pins available in the Arduino boards. Okay, then you have the USB interface which helps to upload your sketch, and also you have a reset button. You have a clock source inside your Arduino. 16 megahertz of crystal quartz clock is running in order to synchronize the operation of your Arduino boards. Okay, so there are many variants of Arduino available. Already you might have seen this first one, which is a Uno, and the second one, which is called the Mega, and the third one is called a Nano, which is of a small size. Suppose you are going for you are connecting more sensors to your Arduino board. In that case, you'll go for a Mega. And you are not it's a very small project. You want a miniaturization of your prototype, and very few sensors are connected. Then you go for a Nano. And there is also a Leonardo board, which is similar to that of Arduino Uno. And then you have the Dew. Then you have the Micro, which is like a little bit of in between version between Uno and a Nano. Okay, and then you have these are the popular Arduino boards. We have Micro, we have, and nowadays the Arduino has come up with the capability of programming. Usually the Arduino is programmed using the C-based coding structure. Okay, so we'll use C-based coding structure, and the inbuilt functions are written on C and C++. Okay, but now even MicroPython is used for programming Arduino. Okay, so now you can even just all you have to do is upload a library, and then the MicroPython can be used to code the Arduino. And there is one more called Arduino R4 Wi-Fi, which is coming with an inbuilt Wi-Fi configuration. So mostly, suppose we are going for an Wi-Fi based project, we'll go for Node MCU boards, right? So the Node MCU boards we'll use to connect the Arduino. Suppose you want a Wi-Fi connectivity, then you will go for Node MCU boards. But now that is possible with that of Arduino R4 Wi-Fi. Okay, and there is also a few boards which is used for wearable devices, LilyPad USB, and Gemma, and these are small devices which is used for manufacturing or prototyping products like smart watches, smart glasses. Okay, in that case, you can go for this type of small boards. All right, so these are the different variants. So next, how to program an Arduino? We'll program using this Arduino IDE, and this is the link where you can download the IDE. And here you just see the Arduino's version, and here you can see the file name. Okay, and then this is a toolbar, and this is the text editor. So here you will have a setup function. The setup function is used for initializing all the variables. So one-time variables, or you want any code to run only once in your program, then you will go for a setup function. Suppose you want to run that for many times, okay, then you will go for a loop. Okay, so it is done by means of a loop. And the programming structure, yes, I told you, this is called as a sketch. Usually we'll call this Arduino programming, this file as a sketch. Okay, and it is stored in the with an extension .ino, and it is stored inside a folder. Okay, it is stored inside a folder. And now the setup function, it is used to initialize the pin modes, start your library, start your serial connections and everything. And the loop is used, any function, anything that you need to run for more than one time, then you will go for a loop. So blinking LED is a well and good program. Any new beginner who works with Arduino will start programming with blinking LEDs. All right. So now, before I proceed with the programming part of Arduino, I would like to conduct a small quiz. Okay, we'll continue the class. So now we are going to see few hands-on how to connect sensors, how to connect motors to the Arduino. So blinking LED is what we know already. We have done this as your experiment. Here, whichever in the setup part, you have to connect pin mode, the pin number where you connect the LED, and you have to initialize that as an output. Then you have to write it digital write that pin number as high, and you have to introduce a small delay so that it is visible for you. Then digital write to comma low, so you off the LED. So when you put this in a loop, okay, so this repeats, high and low repeats, right? And this is how you connect an IR sensor. We have done to connect ultrasonic sensors. So now this IR sensor will sense, and it will show up whether the person is present or not. Like an ultrasonic sensor, it is not helpful to measure the distance, but yet it is used to give the presence of a person. So it will give the output either as 1 when a person, when any obstacles is present, and 0 when any obstacle is not present. Okay, this the working is similar to that of your ultrasonic. It emits a small IR ray. How you use your remotes, right? So infrared signal, the one is a transmitter and the other is a receiver. So it just go hits and come back. Okay, so one is a transmitter, other one is a receiver. So the transmitter transmits the signal and the receiver receives it. So based once if the receiver receives it, then there will be two LEDs here. Okay, so the one LED is always on, which shows that it is emitting an IR light. And whenever something is sensed, okay, so the whenever receiver sends the IR signal coming back, that LED will also glow. Okay, so indicating that a presence of an obstacle is there. Okay, so this is how you will connect an IR sensor. So connecting an ultrasonic sensor, which basically measures the distance, we already know that. And then connecting a soil moisture sensor. So this also we have done this experiment in the laboratories. Now we are going to connect certain motors. Okay, so I'll just demonstrate how to connect motors using this. Okay, so let me connect. Right. So now I hope all of you can see an ultrasonic sensor here. So my hope my camera is visible. Okay, so you can pin that window. Yes. Hope you all can see my screen. I have pinned it. Right. So now you see this ultrasonic sensor. It has three wires. Okay, usually this, sorry, not ultrasonic sensor. The servo motor has three wires. You could see that. So one is this brown color, which is connected to the ground, and then you have a red color, which is connected to the power supply, and then this one is connected to a pin number. So here in my program, I have connected it to the third pin. Okay, so I have connected it to the third pin. So this is the program that I have written connecting servo motors. Okay, so unfortunately I could not see the program here. That's okay, no problem. So how do I connect it? Is usually you'll write servo.servo1. Okay, let me check up. Yeah. So now, initially we'll include the library, and int servo pin is equal to 3, then servo 1, and servo 1 dot attach that to the servo pin. So now I have connected the servo motor to the third pin. Then what I'm going to do here is I'm going to write 0, the 90 degree, and then the 180 degree. So let me check if this program is working. You can just observe this motor here in this video. Yeah, so now the motor is rotated to the 0 degree, then 90 degree, then 180 degree. So in continuous, this is done 0, 90, 180, right? 0, 90, and 180 again. So this is how I have programmed it. So the program that I have attached here, it will take you through that. And here is a link where you can get this program. So for what purpose you can use this servo motor, I'll tell you after executing one more program, right? So I wish to execute one more program where the motor rotates on a particular speed. Okay, speed in the sense not as I am showing here. So it will be rotating based on steps. Yes. So you see that it rotates from 0 to 180 and comes back from 180 to 0. It's all a simple for loop which will help you to do that. Okay, very simple for loop, right? A simple for loop will help you to connect this type. So what is the use of this? Okay, I'll show you a few projects from Google. All right. There are a few projects which you can do. You can do more of robotics based projects using this Arduino, this stepper motor, right? Sorry, servo motor. Now you see here they are generating a small robotic arm. Here is where this motor is connected. Okay, so here is one project where they have done a small robotic legs using this motor. Okay, and here is one more project. Is a YouTube link. Okay, servo motor, using servo motor they just do a small project. And even in your IoT lab, your seniors have done a prosthetic arm. Okay, so the motor that is used in that prosthetic arm for opening of fingers and closing of fingers is this motor. Okay, the servo motor. All right, I'll show you a few interesting projects. Okay, so servo motor is used for all these purpose. All right, you can even also try in your projects this motor. All right. So a barricade type of using servo motor, and this they said that is a small spider. Okay, yes. So you try out small projects, very interesting projects. You can try out with servo motor. Okay, now we'll move on to the next topic where we'll connect stepper motor. Okay, so stepper motor is what I'll show you. Already we have seen servo motor. So hope you can see a stepper motor here. So this is a stepper motor. So this stepper motor, how it is connected is it need a small shield. Okay, you cannot directly connect this stepper motor, but instead you need a small shield of this type. Okay, so this in this shield, so you have pins. Okay, so you have pins where these pins are used to interface to the Arduino shield, and these pins are used to give the power supply. So you will be plugging this motor to this shield, and then you will be connecting to the Arduino um, board. Okay, so this is the motor, and now I have already connected. So this is a small project based motor. This is how I have interfaced. So there are two power supply pins, and this is where you will connect the motor, and there are four input pins, and those four input pins are connected to the pin starting from 8, 9, 10, and 11. Okay, pin starting from 8, 9, 10, and 11. And here is again, I've given a link where you can see this project. You can try this project if you have this motor with you. So, and this is a small program. Okay, so and hash defined steps is 32. So why step is 32? Already I told you, no, in the link they have done a calculation. So based on the number of rotation, they define the steps as 32, and the pin numbers where they have connected the pin. Okay, and then they say stepper dot set speed. So they are asking to rotate in the speed of 200, and I should give the number. You should give the input number through your keyboard. Okay, so I'll be giving it through the keyboard. That is this value through the keyboard, and based on the value, the motor will rotate. Okay, the motor will rotate. So I just give a value. I want everybody to observe the video. So once that value is written, you will see that the stepper motor rotates. Okay, the board has not received its power supply. Okay, so there was a small hiccup in uploading this program. The shield is not working. So once it is ready, I'll show you the demo. So now we'll move on with the next one, the relays. Okay. So this relay is a very, very helpful equipment. It receives low current and it helps us to activate a very big device like your 230-volt bulb or your alarm clocks. Okay, so or your electric bell. Okay, now I'll show you a small demo on how to activate an electric bell using this relay. Okay, so it's sort of an electrical lever like. Okay, so you will turn it on relatively with a small current, and but it helps us to connect to a device which is of a very big one. So this is a relay. This is what is called as a relay. So there are two inputs where I have connected that to an electric bell. I'll show you an electric bell also. Here is the electric bell. So the bell which is connected to your home, the bell how you will connect it, the normal bell which we will use it for your home purpose. Okay, so now I am going to connect this relay to the Arduino board and upload the program, and this relay will activate this bell for 3 seconds. I have done a small program and it will activate the bell for 3 seconds and then it will deactivate it for 3 seconds. Okay, um, so this is a pin out. You will have a ground VCC. So now I'll connect the ground pin to the ground of Arduino and VCC to the VCC of Arduino. And the input, we'll connect it to the sixth pin. Yes, the relay is powered up. You will see a small light. Um, yes, small light blowing up in the relay. All right. So now, and here you have connected NO, COM, and NC. So NO is, I have connected, the connection is shown here. Okay, so suppose you want to activate your 230-volt bulb. Okay, in that case you will take the positive of that wire and connect it to the NO, and from this common you will connect it to the other end. Okay, and then one wire will be a straight. Okay, one wire will be straight. So you can even do this for your projects on activating like home appliances. You can try out this to activate your home appliances, to do an automated door. Okay, so you can even do an automated door based on face recognition, based on fingerprint. Okay, so you can try this. So this project will activate as per this program. It will activate. I want everybody to observe the video. You will get a sound. Okay, you will hear a sound, and you will also hear how the relay is activated. So the bell is activated for 3 seconds and it is deactivated for 3 seconds using this relay. Yes. I'll disconnect it because I have written the program in a loop. So it will be activated for 3 seconds and it will be deactivated for 3 seconds. So this is, you can even, I have connected a small bell and you can connect your lights. Okay. You can connect any devices, any device that draw a large current. Okay. So you can activate that device using your Arduino board. Suppose you connect a Node MCU board here. I'll show you the demo the next week. Okay, using Node MCU board, how do you activate an electric bulb? Smart home appliances, you can do any appliances you can activate using your mobile phone. So I'll show you the demo the next week. So this is how you can do it with using the Arduino automated. Okay, so you can use this relay to even switch on your motors. Okay, your water tanks. So you say You connect a small sensor, okay, and then if the sensor value is below, okay, you take a water tank and the water tank level is very low, then using a relay you can activate the 230-volt motor. And when the upper sensor is senses, okay, so now the water tank is filling and the upper level sensor senses, immediately again the same relay can be used to switch it off, okay, switch off the motor. This can be done, okay. And doors, okay, so when you feel somebody standing in front of the door, then you activate a relay and you open the door. Or you use a face recognition, and if it matches with any of your family members, then the door opens. Finger based, biometrics based door opening, that can be done with this relay, okay. And suppose you feel that any person is coming inside the room and you want to activate the smart bulbs, then that can be done by use of the relay. So this is what I'm using here in this project, is a one channel relay. But you can try out, there are many channel relay, like two channel relay, 8, 16, okay, till 16 devices you can do it with the relays, okay. So all can be programmed using an Arduino, okay. So that was a very smart one available for this. And those people who are interested in robotics, there is a product available, okay, so with the Arduino called Alvic. Okay, so there are many features available in Alvic. I'll show you what are the features available with the Alvic here. So that's very small add-on boards available. There are many add-on boards also available with the Arduino, and one such is this Alvic, and you can use, yes. So you can use this Albic, okay, to build touch mode. Okay, so you can use this, operate this on touch mode. Okay, so you can operate this using the touch panel which is available here. Okay, the touch panel which is available here. And then suppose you want the robot to move front, okay, then left, then right, okay, so you can program it and click a tick button, that will be done in the touch mode. And hand follower, so you want the robot to follow your hands, so you can keep your hands in front of it, and you put it at 10 centimeter, okay, apart, you put your hand, then it does. Then the line follower, the Albic also does like a line follower. So the line should be of this much thickness. Using IR sensors, they have done a smart line follower sensor also, right? So this is one interesting project done by means of one interesting add-on available in Arduino. You can do that, okay? And now even Alvi can be integrated with Jetson board for demonstrating AI-based projects. Okay, you can even program your AI-based projects. You can do smart home cleaner, you can use smart that's what, smart floor cleaner, okay. Then you can even do smart bug predictor, okay. If you feel that the floor should be so clean, okay, so without any bug, then image processing based techniques can be used, okay. So smart weeds, okay, you want the weeds, detect the weeds wherever weed is there, then you should do a small spraying of fertilizer, then this can be done, okay. So this, using this Jetson board, that can be done. And even Arduino is coming with a mini player, okay. A mini MP3 player can be integrated with Arduino. Not only, why I'm giving all these examples is, you not only what we did in your project, okay, what we did in your lab is available with Arduino, but these are all the different features that you can do it with Arduino. And the next one is, you can even do a programming with the RFID sensor. I'll show you the RFID sensor here. And so this is your RFID sensor, all right. And this is the tag that they have provided, okay. And when you program it, and you can just keep it here, all right, and it senses, okay, the sensor senses. You can use this as smart key, all right. So there will be this is a small tag which is programmed, and you keep it, only the tag matches, then it works, okay. So it works. So this is a smart RFID based sensor. First, there are few functions to read the tag. So after you read the tag, you can just do it. And this is also like your ID card, okay. So this is like your ID card. So there will be a small code printed in this card, so you keep it, and you can use this, Okay, is this for RFID scanning? All right, so this you can even print anything over this card, okay, and make this as a smart ID card. All right, smart card or smart ID card. So this is an RFID sensor. You might have not seen this in your laboratory, so I'm showing it. And one more sensor is this rainfall detection sensor. All right, so rainfall detection sensor. Usually we have done soil moisture sensor, but we have not done this rainfall detection sensor. So if you put some water, sprinkle of water in this, it senses the intensity of water and it gives you the rainfall amount of rainfall that it falls. Okay. Now I wish to conduct one more quiz.